Hi everyone. I am François Branciard. I'm working at iExec, and today I'm really pleased to present to you what we experiment with Substrate. Today I will present two things. First, I will present what we are doing with bridges. We have seen in the previous presentation that bridges are part of the ecosystem coming. And then I will present our first proof of concept with Substrate. So the title of this presentation is how to build a domain-specific token-based chain. And I will not read the abstract because it will spoil all my presentation. Okay, so the plan for this presentation, I will briefly introduce you the iExec ecosystem. And I will put it into Web3 perspective. And then I will focus on showing what we are delivering today. We plan to release for next May what we call consortium bridge. And I will explain what it's about. And then I will present our Substrate PoC we have done for a few weeks now. So briefly, I will introduce the ecosystem, iExec ecosystem for those who didn't know. We use blockchain for two things. The first thing is to create a marketplace. So the blockchain is used to seal deals between actors into the blockchain. So when we saying actors, there is three main actors. The first one is resource providers. So that means that servers can monetize their resources. So this is the first actors. And the other actors are application providers and also dataset providers. So we see that all these actors can send orders between them to sell or buy their resources. And then these deals are sealed into the blockchain. And we can see that for the resource providers, we have worker pools and workers. So the network typology is like you have miner pools and miners, and we have entity and worker pool with this typology can have quality of service or provide different kind of services or resources. So this is the first part of the block. This is the first part, the marketplace. And then the blockchain is also used when the deal is done. It's trigger execution, off-chain compute. And so we have what we call the PoCo. It's basically a merchant transaction that proves that the execution is correct. And so you have a trust of the result thanks to this protocol. So it's an all overview of the ecosystem. And to sum up, with off-chain compute, you can extend your dApps capacity. And with on the top of that, we add in an economic game to preserve the trust of the result. And we use the blockchain to create this kind of marketplace for dataset, application, and server providers. So in a Web3 perspective, we are some second layer protocol focusing on heavy computation. And so this is an extract from the Web3 stack. So we deploy our smart contracts for our marketplace and proof of contribution on mainnet, but we also plan to allow others to deploy those smart contracts on their own chain. And this is what for the next release in May, we plan to propose for consortium to deploy this kind of smart contract on their chain. And we deliver intermediary solution with existing technology. That means that we plan to have bridges between the mainnet and POA chain to bridge assets and allow people to build their consortium, and I will explain this in the next slides. So this is for the delivery part for our next release. And, in parallel, we have research and we experiment with Substrate and the Polkadot ecosystem. And the idea is instead of using bridge under a proof of authority, we can delegate this relaying messaging between chain to Polkadot, and Polkadot will have this own incentive to do this relay. So it's part of our idea about that. And we also need what has been presented in the previous presentation, all these kind of governance models and other things like that. So our ultimate goal is to have an autonomous chain with their own incentive and also all the governance parts that is in research now. So this is two aspects I will now present. So the first thing is consortium bridge. We start from the parity bridge and then we use POA network token bridge. So they introduce the possibility to bridge ERC20 to ERC20. I don't know if you are familiar with bridge. Maybe I can explain in one second. So bridge, you have two contracts. You have a contract on the mainnet and a contract on your POA chain. And you can allow people to transfer assets in this contract. And some software watching the transaction from the main contract and create the assets on the other side of the bridge. And the other side, it's your proof of authority chain. So there is no supply creation. You keep the supplies of your asset, but you can bridge your value on the other chain. And so you can think like deposits, and then you can also withdraw and coming back to the mainnet. So it's the basic overview of what a bridge can do. But we needed also for consortium to do not support everybody coming in their chain because as you cannot block somebody to transfer token, we introduce a feature proposal to have a whitelist of people that can cross the bridge. And so we currently contribute on adding this new feature to the POA network bridge. So I will illustrate what kind of use case it can do. So imagine let's build a consortium. You have application verticals. You have a company that can be the data provider. They have data that can be that can be used to train models. And you have another company that have application. And the third company can have, for instance, idle resources of GPU. And for instance, it's when proof of work will be story, maybe there is idle GPU that can be used for all those other tasks. So each company can represent an authority, and they can join together to automate their business. So this is the first case. They can automate their business, and each providers will deploy the dataset, application, or worker pool. It's like their reference. They deploy their reference for their resources. And they gain the shared auditability of the usage between them. And that means that at the end of the month, they can see what usage they have to pay each other. So this is the first level, building this POA without bridge. And we will see that we can add other levels of features. So when you can introduce a bridge under the same authority, and this can automate token payment between them. So each time one authority can deposit and withdraw, and then all the auditability and transaction are in the PO in their home chain. And the cool feature that is they can add dynamic prices for their resources. So this is the second level we can add some feature. And then they also can have a joint customers. That means that if the formula is like this, if this user or customer trusts this authority and like the efficiency of the services provided by those company, and if this authority whitelist the user is able to use this asset into the home chain of the POA. So this is the kind of use case we see useful for consortium. And so what's happened if you are not whitelisted to cross the bridge? So there is like a sonic loop that as we cannot block transfer, ERC20 transfer, in fact the bridge have to refund the user. So the asset is given back to the user. And today in bridge you can add also fees smart contract. So that means that here only fees will be removed from the transfer. So it was for the bridge part of what we are currently working on. And now I will present you what we experiment with Substrate. So the idea is we start with the Substrate template node modules. It's like a minimal blockchain with some basic modules, and we try to add custom modules on it, and we're focusing on the proof of contribution part when we modelize task and contribution for off-chain compute. And it is the economic game incentive part of our platforms. Our objective was to familiarize ourselves with wasm and the next technology to come, and also see the difference between working with smart contract and runtimes, and also all the governance module we need today for something like if you have a domain chain, the block production policy, upgradability, and all this kind of governance that need to be solved. So this is another graphic from the stack, and you will see that the PoC only cover the contribution part of all the stack. So I will briefly introduce the contribution reveal schema to understand later what the PoC is about. So if you have an off-chain task, the workers have to do two calls. The first call is what we call contribute. That means when you contribute, you have to stake. And for the contribution, you have only two parameters. The first parameter is your result vote. That means that at some point, many workers will come and vote, and at the end, there will be a consensus of the vote of the result. So this is the first part, the vote on the contribution. But this vote is somewhere hidden. So this is the second parameter is contribution seal. And this contribution seal will be used later for the reveal phase. So every worker contributes, and at some point there is a consensus, and that means that all workers are invited to reveal, and at this time they only provide one parameter, what we call contribution unsealed. And when they reveal, they get reward or slash according to their valid or wrong contribution to achieve this off-chain task. So the next slide is the same thing, but just look at the colors. You see that when you vote, there is 2 levels, and so the contribution is sealed. And when you reveal, you basically reveal one part of the previous level. And in fact, the runtime or the smart contract, and the runtime or the smart contract check that the result vote was valid, and also the contribution seal was valid, and then so after that they can trigger payment to reward actors like workers. No. So it was just an introduction of our economic game for the off-chain compute, and so we try to modelize this economic game and code into Substrate. Today we have developed this into smart contract, and we wanted to see what the difference between smart contract and writing this kind of code in Substrate runtimes. So Substrates come with some basic modules. So you have basic module of blockchain like balances, consensus systems, and of course you can customize it, but also you can add new modules for your own logic. And here I introduce a new module, iExec module, into the runtime. So you can define your some models. Okay. Here I only describe the task and contribution, so simple modelization. And in the contribution, you see the 2 parameters I have talked about, the vote and the result seal. When you have a runtime, you also define a storage. Basically, here is a mapping of all tasks and all contribution into the runtime storage. And like in smart contract, you have function you can call. Here you define your functions that can be called by wallets. And here there is a function to create task definition, and then to contribute on those tasks and to reveal on those tasks. There is a Substrate interface that allows you to quickly test your new runtime. So you run your blockchain and then you connect your interface to this runtime, and you see that in the console you can access the runtime, then your module, and then all storage or function of this module. So here I create an interface for creating tasks, and then interface to contribute and reveal. So the contribution, you need the task ID on which you want to contribute, and the 2 parameters we have seen, the vote and the seal of your contribution. When you contribute, you stake and contribute, and when you reveal, you will reveal your 1 parameters, and you get reward if you are part of the consensus. So we create accounts. Scheduler is like the manager of a worker pool. And we also create a worker's identity, worker 1, worker 2. So in reality, the replication is more complex than only one number. There is reputation and a score. But here I simplify the replication. So when you create task, you ask to the number of replication you want to achieve for the consensus. And then we can see that the task is created and no contribution has been received yet, so there is no task consensus. After that, workers contribute on this task. They have the same votes, so we will reach the consensus of the option task. And the sealed part, the last parameters, is different for each workers. So the consensus is reached, the task consensus is revealed, and that means that all workers can have incentive to reveal to get reward. And the workers reveal, and so at the end, as he is part of the consensus, he gets rewarded. So basically, it's what we experiment, and it was quite easy to implement new logic and with Substrate. So I think it's a really great tools to quickly bootstrap some chain logic, and yeah. And I will finish on speculative ID with what we can do further. So I see that, in fact, you can build a specific logic and for your chain, and at some point you will have also different performance needed between use case, or security or governance will be different. So it can be easily customized for each use case. But at some point you want to have interoperability between your domains. And it's where I think Polkadot is a key part that allows this cross-chain message passing. And you can imagine that if you have a domain-specific chain like iExec that do option compute with this optimized chain for doing that, like we have seen with task replication, own game incentive for option task. And on the other part, there is another domain like donation. We can imagine that Givet or Alice have different security models and different logic to do. For instance, they raise money, they have milestone, and this is a different topic. But at some point, if we can bridge them together, we can create this what we can call DCO, donate computation offering. That means that when you will do a donation into Givet or Alice domain chain, you want to be sure that your donation is used to compute this kind of application only, and you can track that your donation is well used. So to do that, we can do bridge between one solution is to doing bridge between the two parachain or two chain. But if you have an external actor like the government, and you have to have task deduction because you have done this donation, maybe the government do not trust this parachain, maybe because of the security is not as high of other chain. And if it do not trust both parachain, you will do not trust the bridge between them. And maybe it will be okay if you have a proof in this Polkadot relay chain that is a third party And you can imagine that you will prove into this relay chain some non-reusable proof, like that you have done this donation, and then the government will be okay to give you tax deduction. So it was a speculative idea, but to introduce what interoperability can enable. So I will finish with this slide. So we see in the Substrate Roadmap that off-chain compute is a topic arriving. So we were really happy to see this off-chain topic coming. And we see that we are, for the economic game, we're working on a proof of contribution, and for organized group of executive tasks, we have this worker pool network topology. So I start with substrate meet iExec, and I will finish with iExec meet substrate. And we're really happy to have this common vision and synergy bit on this topic. So yes, thank you for your attention. If you have any question? Okay. Thank you.